Yes, okay, okay. Your voice is breaking.
So let's start with today.
तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा
Some noise is coming.
ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीम् वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीम् पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीम् बुद्धिप्रदां शारदाम्।
एक चीज कभी कभी इमेज बिगड़
Some disturbance is there.
Am I audible, sir?
Yes,
Hello?
yes, you are audible. Yes, yes. Yes, yes, you are audible.
Very good morning to all. Good morning to all. Very good morning. Very good morning to all. Very good morning. It's my pleasure and honor to start. Thank you, thank you, sir. In order to start the inaugural.
The voice is breaking.
Very good morning to start the job training.
Some-
It's my pleasure training.
Your voice is not clear to me.
Now it's okay, sir.
Yes,
Is it okay?
I will start. Yeah, your voice is breaking here. Can I start? Can I? Hello, I'm not getting your voice. I'm not getting your voice.
I'm getting your voice, sir. Is it okay, sir?
I am audible.
I'm not.
I am audible.
Yes, sir. Yes,
Okay.
sir.
When I will start, just tell me.
Yes, sir.
When I will start,
Yes,
just
sir.
tell me.
I, Dr. Dhanvir Kumar Yadav. Yes, sir. Sure, sir. And I would like to thank welcome invite you to say a few words.
Okay, thank you. Thank you. Introducing me. So can I start now? Your voice is not here clear. I am audible?
Yes, sir, you are audible, sir. You
Am
can
I audible?
You
Okay,
are
thank
audible,
you.
sir.
you are
Okay,
audible.
thank you for introducing me. Dr. Ranjana Kumari, Principal. Dr. Dharamveer Kumar Jadhav, Coordinator of the program. The organizing committee. Faculty members of the CSE department. Katiyar Engineering College. All the participants from various parts of India. And it is my pleasure to be here as a chief guest. I am thankful to the organizing committee for the invitation. We should be thankful to AICT, All India Council of Technical Education, for encouraging such type of a program for development, faculty development program. It is good. Department of CSE, Computer Science and Engineering of Katiyar Engineering College has an opportunity to explore the hot topic nowadays, robotics. In these 5 days from day 1 to day 5, you all will come across various experts from well-known and important institutions and organizations. I expect the course will be definitely useful to the interested faculty members. Those are interested, and all interested faculty members will be benefited from this. Researchers and research scholars who are hungry to learn, even to enthusiastic PG students. For this, that is to design intelligent system, knowledge of artificial intelligence will be highly required. We have seen from TV, WhatsApp messages, how a robot works. Interesting things are already developed by various countries, including India also. Anyway, industry also plays a very vital role in designing robots. Most focuses are on the mechanics and control of the most important form of the industrial robot. That is the mechanical manipulation. Functionality of a robot solely depends on the description of position and orientation. As you know, the kinematics of manipulators, the number of degrees of freedom that a manipulator possessed, inverse kinematics of manipulators, velocities, static force, etc. These are some terminologies used in designing and functioning the robots. My dear friends, you should be very careful about the terminologies. You have joined this program to develop, to do something research, to develop, design some robots. So that is why, what is the principle behind it? You only learn a lot of things from the experts. In order to understand many of these, we can borrow two items basically from mathematics, that is vector and matrix. Vector represents a position and a matrix is used as a operator. If you open any robotics books, these mathematical concepts are very much important. So matrix here will be used as a operator. When you are using matrix as an operator on a vector, again you will get another vector. Vector gives position and you will get some another position because robot moves from one position to other positions. Trigonometry also plays a vital role in this understanding the robotics part, because angular movements of those things can be calculated by trigonometrical functions. So now what I can say that, so mathematics is the important part of robot design and we can get it. Hence we cannot forget, or without clear understanding of mathematics, without good knowledge of mathematics, so robot part will be very much weak, because intelligence is required and intelligence is developed by mathematical functions. Working of a robot is nothing but a function. You have to define one function and you have to get it. Hence, from all the experts, those are speakers are there. They will, I think, they will try to expertise you in these areas. Of course, it is a combined effort of three departments basically: the mechanical, electrical, and computer science engineering. So now if as a combined effort will be there, definitely lot of good understanding, cooperation, although things can be there, and we can, with the cooperation from the different branches of engineering like electrical, mechanical, or computer science, even mathematics. So good robots will be there. Nowadays you have seen that robots are used in healthcare systems, agriculture system, even with hotel management. Even time may come, robot may teach you. You will act as a teacher. All intelligence will be fed to the robot. So how intelligently, how artificial intelligence subject is playing the vital role along with the machine learning concepts and evolutionary computing. So that will be the practice of everybody's nowadays. So have a good knowledge of about these subjects, then definitely this important hot topic nowadays, robot text, will be beneficial to you. So now, so I have again, I am thankful to the organizing committee inviting me for such things. So although I have now, I cannot give more time because I have to start. I have a class from 9 o'clock. Actually, I have taken 10-15 minutes from my students to start my work. Anyway, I bless the people all, and all the best for the organizing committee, and my best wishes for a good competition for this the great successful of this program, faculty development program. Again, thank you, Dhanbirji, for inviting me and as a organizing committee. So let me stop here because I have to start my class.
Thank you, sir. Yes, sir. I had promised you to leave before 9:15. So you have class. So thank you, sir, for joining the session. Thank you, sir.
Okay, thank you very much.
Yes, sir. Thank you, sir.
All the best for the program.
Thank you, sir.
So I'm leaving.
Yes, sir. Yes, sir. Okay. Uh, Now I invite our respected principal, ma'am, Dr. Ranjana Kumari, to say a few words. Ma'am, am I audible? Ma'am,
Hello, am I
yes, ma'am,
audible?
you are audible. Yes, yes, ma'am, you are audible, ma'am.
Very good morning to all.
Welcome you, ma'am. Yes.
Thank you, thank you. Very good morning to all. Thank you very much, Sahu sir, who took out his time and agreed to join us today to be a part of this FDP. We are honored to have you with us, sir. I welcome all the participants from all over India in this online 5-day Atal Academy sponsored FDP on robotics. It is my privilege to address you on behalf of Katihar Engineering College, Katihar. We are truly delighted with your presence. This program is being organized by Computer Science and Engineering Department of our college, the coordinator being Dr. Dhambir Kumar Yadav. I also take pride to pronounce that out of 38 government engineering colleges in Bihar and many others, except NIT and IIT, only Katihar Engineering College got the approval and funding of Atal Academy to organize this FDP. It could be made possible only because of the awareness, zeal, timely and tireless efforts of Dr. Yadav. Dear participants, I also want to let you know that this college has been established just 5 years ago. But in spite of all hurdles around us, our creative, innovative, and motivated faculties are trying hard to establish this college as premier institute of the state first and then of the country. Closing the speech, I hope everyone is well aware of the themes concerning FDP. We have a great time ahead having you all. To conclude, I wish you all great success in your pursuits. Without consuming much time, I am handing over for further activities of the program to Dr. Yadav. Thanks.
Thank you, ma'am. You are always inspiration for us. Thank you, ma'am, for joining this inaugural ceremony program. So,
Thank you.
yes, thank you, ma'am. This is 5 days online faculty development program sponsored by AICT Training and Learning Academy. So, during 5 days program, we will have total 14 sessions, where 13 session will be the technical session, and one session will be for yoga. So, live yoga session will be done by yoga trainer. So, the eligibility criteria to attend this FDP program was the participants had to register through AICT portal, and the participants are from AICT recognized institutes, faculty members, and participants from industry, host institutes and PhD students and MTech students. So at the end of this program, we will have a test. So criteria to get a certificate from AICT, you must have 80% attendance and you must have 60% score in the test. So we will conduct test at the end of the program, and every day we will have attendance. We'll share a Google form to collect the attendance form, as well as we have having automatic attendance recording by Cisco WebEx. And so once FDP will be completed, so you will be able to download the certificate. But it will take 2-3 days time. So once I will finish the uploading of attendance and marks, score marks of your test, then you will be able to download the certificate. But before uploading the attendance, and I will share with all the participants your attendance and whatever the marks you have achieved in the score, in the test. So if you have any problem, you can contact me through a mail. So that's all from my side. So now I invite Dr. Vijay Bhaskar Semwal. He has joined with us. So we have next first technical session by Dr. Vijay Bhaskar Semwal. So I think he has joined the session. So before I introduce about the Vijay Bhaskar Semwal, yes, he has joined. Welcome you. Am I audible, sir?
Dharmesh sir, you are audible. Bhaskar sir is not audible.
Okay, thank you for your confirmation, sir. Vijay Bhaskar sir, I'm making you organizer, presenter. Yes. So I request my co-host Talib sir to make Vijay Bhaskar sir as a presenter.
Yes, sir. Now audible, sir. Am I audible?
Yes, sir, you are audible. Yes, sir, you are audible.
Thank you,
Sir. Thank you.
Thank you.
Yes, sir. Thank you for joining the session.
Thank you.
So I will introduce Dr. Vijay Bhaskar Semwal. So Dr. Vijay Bhaskar Semwal currently working as assistant professor in the CSE department of MANIT Bhopal. So before joining to NIT Bhopal, he has worked as NIT Rourkela, NIT Jamshedpur, IIT Dharwad in CSE department. Also, he has got offered to work at NIT Hamirpur. He has also worked as a senior system engineer at Siemens Noida and software engineer at New Gen Software Technology. Sir has completed PhD from IIT Allahabad in robotics, and he has also completed MTech from IIT Allahabad. Sir has more than 7 years of teaching and research experience. Sir has got ACRB International Travel. Sir has got ACRB International Travel Support Grant to attend and present the paper for IEEE at Singapore, funded by ACRB Department of Science and Technology, Government of India. Sir has received IEEE. Sir is a reviewer of IEEE transaction, IEEE sensor, and many more journals. Sir has also organized many international conferences in India. Sir has delivered invited talks in India as well as in international other countries like Singapore and Bangladesh. Sir has published more than 50 research papers in SCI journals, so in which he has published more than maximum papers in IEEE. So welcome you, sir, for joining this session.
Thank you, sir. Thank you, sir. Thank you for kind invitation, sir. So should I start?
Sir, you can start your technical session, sir.
Okay, sir. I'm sharing my screen, sir. So now you can see my screen.
Yes, sir, it is visible.
Okay. Okay. So thank you for the kind introduction, Dharmesh sir and Dharamveer sir. Sorry. And good morning to all participants. And this is, I think, that first session of 5 days Atal workshop. So it is my privilege as well as really it is my pleasure to present here work. So in this talk, I will try to keep as simple as my presentation so that participant can get benefited. They can get introduction with the robotics technology. And especially my topic of my talk is introduction to bipedal locomotion and push recovery. So two behavior which is very essential for robot walking on humanoid robot design. That things I will discuss. Currently, I am working at assistant professor CSE department, and apart from there, I am also associated with IIIT Bhopal at IIIT Gwalior. So, okay. And what I request from participant, if any moment of time they are finding any difficulties in understanding, they can write in chat box, and they can stop me also. They can ask. Okay. Otherwise, I will provide 15 minutes in the last so that you can ask or interact with me. Okay. So first, I'm going to introduce what is bipedal, what is humanoid, and robot. So almost everyone is aware of what is robot. So the various type of robots you have also seen, mobile robots, humanoid robot and bipedal robot, both are we are using together. Both are same thing. So bipedal means which has two limbs, two legs like human being, and humanoid also which is very similar to human architecture. So human being has certain degree of freedom. So we used to move our hand, we used to walk, and the walking behavior. It is only possible once we have certain degree of freedom. We have hip joints, we have knee joints, we have ankle joints, and they have certain degree of freedom. So degree of freedom term is here. Number of independent axes are required. That means one joint without helping another joint, if I can rotate. There is two kind of joint in robotics. One is revolute joint, another is prismatic joints. Revolute means which you can rotate. Prismatic, which you can slide over another. And there is various other joints are also available. Okay. So in this talk, I will keep focus on revolute joints, which is moving, and they are moving independently. It is not like that your knee is moving with the help of hip. Then it is not independent. Independently we require. That means knee will join separately, ankle will join move separately, as well as hip joint will move separately. And you also have to understand, if you have knee joint, then only you are able to jump. If you are unable to fold your knee, you will not able to jump. Okay, so let us come on what is locomotion. Locomotion is related to walk, and in this talk, I will give some future aspects to start research also in which you can work. Okay, I will give the various locomotion strategy, locomotion style. What is the important of different species, how their locomotion has evolved. All sort of things I will discuss. So let us start. First, understand locomotion. For this, I am playing one video. You can see this video. Are you able to see this video?
Yes, sir.
Yeah. Okay. Voice is not there, but the video is there. So if you see that, this what is this video? This video, you see that white color. These are showing the joints. And when computer vision we used to apply, we used to put white color and black color entire body so that we can differentiate between joints and other portion of limbs, shoulder or elbow, or and you have joints, hip joints, knee joints, and ankle joints. If you see that this is stable walk, the person is walking with the coordination effect of left and right leg. So we have both left and right leg coordination. At a time, one foot is in the air, another foot is in the ground. And the similar, you can see that. So both foots are coming in the air, placing on the ground, coming in the air, and that means heel strike and toe of two events are there. What is this? When your one foot is in the air, that is considered as a swing phase. And when one foot is in the ground, that is stance phase. So during one walking cycle that I will define later on what is gait, but you just understand locomotion. It is flexible motion of human being by which we used to move forward. Similarly, if an animal has its own locomotion, if you see that fish, they used to swim. If you see any reptile, They used to crawl and other kind of things. They have locomotion by which we used to move from one direction to another direction. The another essential behavior which I'm going to discuss, that is my push recovery behavior. Here some model is there, simulated model, in which some external force we are applying from behind. Okay, and slide is this is moving from behind, and we are able to recover. So human being has some bounded push recovery capability. That means up to certain extent we can recover from outside force. Okay. So human being has bounded push recovery. It is not like that infinite force we can sustain. We can sustain only for few newtons, like 12 newtons. It depends on your capability or even your learning abilities. Now the questions are coming. There is various type of robots, mobile robots, bipedal robots. I will give the example of different bipedal robot available, how they are working, what is their working mechanism, okay, how it is evolved. Before this, we have to understand why we are interested to understand the bipedal robot. That means which has two limbs, or which is humanoid robot, which is very similar to human being. So that question we have to address. So three questions I will address here: why bipedal robot, why push recovery capabilities required, and then what we expect from bipedal robots. So first, what we are expecting from bipedal robot, where we can use. So they have a lot of application, and generally they have divided into 4D environment: dull, dirty, dangerous, and difficult environment, where they are supposed to work. Dull environment, repeated tasks. We are sitting in the bank and performing same task from morning to evening. So human being will get tired. So in this case, robot can be replaced. And we have designed our infrastructure for human being. We require the similar machine, or that means human being is also agent and robot is also agent. There is software agent also in artificial intelligence, which is mimicking the human capabilities. That means they have learning capability also. And I will show the example of Atlas robot, which having capabilities of, they are working very similar to human being. Okay. The question is coming bipedal robots. So first I was discussing about environment. So domestic environment like home environments, hospitality industry, hotel industry. During COVID time, they are also using at the airport, because the interaction with the people can affect you with the COVID. So to avoid this one, what you can do, you can replace by the bipedal robot, which can scrutinize or check the person, so that the person cannot get affected with the such kind of diseases. Dangerous environments, if you see that bomb disposal plants, if human being is going, it is leading for the human casualties. Maybe human being can die. Some difficult environment is space exploration, where robots are going. They have to go in the Mars and other surface, and then they have to bring certain soil and other kind of things for investigation purpose. Which kind of land are there, whether it is human survival, whether there is water or not. All sort of application area we are deploying the humanoid robots. Dangerous environment like you have seen in Dhanbad and other, there is coal mines. The human being and labors are going, and many times what is happening, harmful gases are coming. It can lead again for human life. So to save human life, we can deploy the humanoid robots, bipedal robot. But just we don't want locomotion capability, moving. This is not sufficient. We require push recovery. That means if any external obstacle is coming and it is hitting me, I should recover up to certain extent. That is my objective. That's why I'm going for locomotion for push recovery. Another benefits apart from these application area, it help us to explore the human autonomy, how human structure is designed. We used to analyze, if we'll try to analyze the human behavior, walking behavior, this walking behavior help us to understand the human cognitive behavior also. As we know that as you grow elderly, you will become older person, your walking style will change also. You will find difficulty to walk. So we can understand these sort of things, how human babies start walking, and after that, once it has acquired this behavior, then they are comfortably walking, and after certain age, it is decaying. So there is mechanism, motor skills. Human being has motor skill, which we used to learn. Okay, So like as baby, we are not knowing how to walk, but after certain time we'll start learning. After 2 years, then we start walking very comfortably. After certain age, like 50 or 60, we'll start losing our system. So due to cognitive decline, that means neural system are going to die. Human beings are losing their walking pattern. Apart from there are certain diseases like Parkinson, freezing of gaits, paralysis. After this disease also, it is affecting the human walking style. Okay, so this study is not only helping us to design the bipedal robot, it is also helping us to assess the human health. We can monitor the human health. You can also monitor certain robot simulator available, which maybe other sessions I will discuss, in which you can analyze your daily activities, how your daily activities is moving, and either you are going to suffer with some disease, you can easily identify at earlier stage. Third thing is that it is unique biometric item. Human walk, which is I'm defining as locomotion or GAIT, gait. This term also I will use, gait, for human walk. So human being has different gait style. Tiger has different gait style, GIT gait. Okay, that I will refer this one. Locomotion or gait, or especially the talk is related to human being walk or human being locomotion or humanoid locomotion. How we can design the humanoid robot with the help of human locomotion. So human locomotion is going to study for the purpose so that we can develop the robot walk. We can understand the problem of human beings. We can also understand the mechanism how human being is learning this behavior. That is such a complex behavior. If you see that if you are a healthy person, you can walk very comfortably. But if you are a drunken person, why they are troubling? They are not walking very steadily. If you ask to follow a straight line, they will not able to follow. So it is affecting our nerve system also. Okay. Apart from there, one is important behavior. If you see that human being has capability to jump any obstacle. If any obstacle is coming, we can jump or we can negotiate with this one. We can change the direction. How it is happening? Because we have knee joint. With the help of knee and hip joints, we are designing such a motion so that we can jump. If you have no knee joints, effectively you cannot jump over any obstacle if it is coming on the way. Okay. So we have ability to step over uneven surface. Okay, flat surface, laboratory environment, it is okay. But outside laboratory, you require such capabilities. You require push recovery. You require human efficient, human kind of working capabilities. And this human walk is defined as a reflexive behavior. The term when I'm telling reflexive, the meaning of reflexive is that like you have seen reflexes, it's automatically you are learning, and the moment the situation is coming, you will try to reflect that behavior. You try to exhibit that behavior. Like I will throw ball over you, you will try to save yourself automatically. Okay. So this is what reflexes. Similarly, your human walk is that whenever you are walking, I don't think that you are using much brain also there. They are not applying this much strategy. You have to move left and right. You are simply starting walking. Those when you are climbing over different height of staircase or very dangerous terrain, that time you will use. Okay. This study is further helpful to design the artificial limbs for the physically or differently able person, challenged person. Okay, so assist the elderly subjects, physically challenged person, help amputee to recover their walking pattern as well as to design their exoskeleton. Exoskeleton is a device which help us to we used to wear, and with the help of this one we can walk. Elderly subject can walk. Even person is suffering with the one leg, okay, still he can start walking with the help of exoskeleton, such a device or hardware which you can wear, and it can help you like as a leg and other things. Okay, the term biometric identification is that like we can identify human being very uniquely. We can identify human being very uniquely. So like face recognition, your palm detection, your signature, there are different biometric traits. There is two kinds of biometric. One is physiological, which is related to your physical structure like face, palm structure, other things. Another is that behavior-based biometric, which you have acquired through continuous interaction with the environment. That is walking, gait. Gait is very unique. Each and every person can be identify the walking by seeing video You are traveling through the CCTV cameras, and we can, if you are traversing from there, you can start checking there. Okay. Second thing, video surveillance purpose, we can install this study. Okay. So it is very unique biometric identification, and for any biometric identification, generally we expect it should be permanent, it should be universal, it should not changing too frequent. Okay. And each and every person should have working capabilities. Each and every they should have such capabilities so that we can uniquely generalize. Okay. So now I'm coming on some interesting study. You can understand post recovery. So generally, robots are supposed to work in the human habitable environment where human beings are staying. So they will climb over a staircase, they will come down staircase. In this case, they require such a autonomy or anatomy, which is very similar to human being. So that is one motivation. Other things that if machine to machine interaction is possible, robot are playing, their group behavior is required. In artificial intelligence, generally we have sense, plan, and act. Through sensory organ, we are sensing. Then we are planning, which is controller level things, and then we are acting, which is our motor skill, which effectively we used to learn. Human being used to learn. So through eyes or sensory organ, you are taking inputs. Then you are planning kind of things, controlling. The brain is learning this behavior. Once it is acquired, then your motor skill is trained, and the motor is acting on behalf of particular inputs. This is what AI. Okay, modern AI is sense and act also, but planning is not there. In this case, reinforcement learning thing. But traditionally, AI, we used to learn science, plan, and acting. And planning somewhere you can understand some neural system or neural network you are learning. So there is, we can have person to person communication. That means single to single person intelligence. We can have group intelligence. Like you are playing cricket, that time your group behavior is important. It is not like individually you are playing very well, but combined effort is required. Okay. Apart from there, it is expected that they will work in the with the human baby. They will play. They will serve the elderly subjects sitting in the house, which is physically challenged. And nowadays, elderly people are totally alone at house. So that time, bipedal robot can help them to serve them water and other. Okay. So one behavior which I will show you, which I have done during my PhD. If you see that this is HOPE2 model, HOPE2, HOPE2, human open architecture environments. In this case, what is happening? The ball is coming with the 1 Newton force, F equal to m into a, mass is uniform. The acceleration with the 1 meter per second square, and acceleration you can measure through the accelerometer. In the afternoon session, I will teach you how you are identifying human activity recognition using various sensors, accelerometer, gyroscope, magnetometers, how you design the deep learning models. All. So the body was not able to recover this humanoid robot because there was no strategy applied. But once we have written the controller for the, and we have implemented ankle strategy, same magnitude force is coming, and this time it is able to recover. So I'm coming on this 3 basic strategy of force recovery. It depends on the magnitude of force, what magnitude of force we are applying. There is small magnitude, little bit more magnitude, and more magnitude. So as we told that human being has bounded force recovery capability. The meaning of bounded that we can sustain from the external perturbance or the force up to certain limit. It is like 12 Newton, 30. Infinite force we cannot sustain. Ultimately, we'll get fall. Okay. So if force is very less, in this case, what is happening? Just I'm involving the torque against the ankle. Okay. Reverse torque is generating around ankle. So I'm using only ankle. This is considered ankle strategy. Another is hip strategy, in which I'm involving ankle and hip when magnitude is a bit more. And the demonstration I will show how we have captured the date for human being. And after that, third one is that stepping. You will take the step to recover from external force. If you see that this is your green color dot, this is your center of mass, and this is a ground reaction force. The force which is applying against you from the ground. Okay. So the trajectory, the projection of center of mass is passing through ground reaction force, or this ground reaction force trajectory passing on the center of mass to body is static. In this case, dynamically we are moving. but we are not unstable because we will recover if we will apply the torque against hip and ankle. Okay, and another case I'm taking steps. So there are 3 strategies by which human being used to negotiate with the external board. And human being is the best example from where we can learn any sort of behavior. If you have seen the optimizing techniques, anti-cloning problem or geographical and other things, they are all inspired from nature. Nature inspired. The things that nature is the best teacher, and more than nature you cannot teach better. Okay, so that's why such situation. And we in the sense robotic community has also evolved the robot push recovery according to these 3 behavior. Okay, so you can read Jerry Pratt. Now recently he has joined Boston Dynamics, and I will show the video of Jerry Pratt also. He's working on Atlas robots. So there is always human architecture is understood by as a problem of inverted pendulum. Like you can understand human baby. Why it is taking 2 years? If you compare with the quadruped animal like elephants, dog, they will start walking within few hours of the birth. But human being used to take 2 hours. But still we are interested because there is certain benefits. Our walk is very energy efficient. If I will say that energy efficient, so whenever you are writing on your notebook, you are always making 90-degree between elbow and the shoulder. The reason that is the optimal joint angle. If you write like straight, you will get tired. You will require maximum energy. As well as in this case, we require such a motor which can generate the infinite torque, and such motor is not here. So in this case, what will happen? Motor will get burned. So such configuration is defined in the robotics. So the day I will introduce the kinematics of robotics, the mathematical foundation of robotics. That time you will understand singularity. Singularity somewhat you understand. You cannot find the inverse of matrix. The matrix is not invertible. Okay. So maybe its determinant is 0. So we have a defined human architecture as inverted pendulum. And to make inverted pendulum, we have to apply certain forces. With the help of certain forces, we can balance the body. So stability is there, locomotion is there. So stability somewhat push recovery, stability also is there. So there is some TJT they have deployed. Displacement versus acceleration. Okay. So they have the velocity, sorry, displacement versus velocity they have plotted. And if you are seeing this red, this is stable region, and green region is stable. If you are falling outside of this region, then it is not stable. You can read this paper, Capture Point, a step toward humanoid push recovery. Okay. So already I introduced locomotion. Now I'm trying to open you the area in which you can start research working as an undergraduate, as a postgraduate, or PhD students. Okay. So locomotion simply in definition, moving from one place to another. If it is human being, we are moving with the help of leg. If it is dog, with the help of 4 legs. If it is fish, then they are swimming. Okay. Similarly, you have reptile, you have lizard, chipili. So they are also climb over a wall. We cannot climb. So different species has different benefits and drawbacks. So now what I will do, I will introduce the legged locomotion, which is especially humanoid locomotion, bipedal locomotion. Then little bit we'll see what is passive walk and dynamic walk. So passive walk in the sense that which is not using any motor controls. Okay. So passive with the help of certain joints and with the help of like gravitational energy, we are moving the direction. We have no knee joints also. Dynamic walk where I am applying some motor and then we'll see that how they are actuating their joints. Then ultimately I told that human walk is very optimal. So this is target where people can work optimal walking strategies, optimal gait, optimal push recovery strategies, these things. And motion planning in 3D. How you plan the motion of. So the question already discussed why bipedal locomotion is required. So if you are finding any difficulties, you will not hear me, and you are finding difficulties in listening me, then also you can write. I will repeat the things. So bipedal locomotion already, we have tried to understand the biomechanism, how human being walks. Because the human being is the best gift of the and special species in the society, which has too much abilities. And we are trying to design the robot which can learn through the ability of human being. That's why we are trying to mimic. All things are human inspired or nature inspired. We are trying to understand that biomechanism, how motor joints are learning, motor skills are going to controls. Okay. So brain has also motory neurons, sensory neurons through sensor which are taking inputs. You have visual sensors, you have audio sensors like your ear, and there is different receptory sensors or muscles in the brain which used to receive, because human brain is not as a single cell, it is discrete cell. Different portion of brains are activating for different activities. Then design of active prosthetics, that means we can design the artificial legs, exoskeleton. We can also understand the effect of disease, how post-disease, pre-disease, post-operation, pre-operation. You can see that also sports person are suffering with the walking disabilities. They are suffering with the hamstring and other things. That time also you can suggest particular exercise by analyzing their working history. Okay. And second thing, robot living in the society need to have human-like feature, like we require hand, leg, 2 legs, and face. Okay, so that we can identify uniquely. All man-made structure are designed for human habitation, human architecture. Your staircase, your wall, your windows, all sort of things are designed for human. Last but not least, in entertainment industry, you have seen the robot movie also, the Rajnikant movie. There also you have seen the capabilities of robots. Though this is somewhat not real life, it is real life, but still it is motivating points what robot can perform. There they are shown the AI's capabilities, how robots are learning the behavior, they are falling in love also. So that is quite unpractical right now, but it is not impossible. Okay. In the movies, toy games, you have seen that puppets. So in the Jaipur, you can see that they are using Katputli shows puppets. And human and robot interaction, like you are playing, or they are serving in the hospitality industry, hotel they are serving, they are bringing a beverage and all sort of that time we need to, and rehabilitation, like sports person rehabilitation. Now, if it is the motivation portion has finished. Now, how evolve? What is the importance of leg and their position and their length? So how many legs? That is also important. Whether it should be uniform length or they have different length leg. And what is their position? Where they are placing. So if you see that in robotics, I will introduce later on what is frontal plane. If you are seeing me from front direction, that is my frontal plane. If you are seeing the left and right side, that is my sagittal plane. It is written. And if you are seeing from top view, and you can understand this is very easy, that is cornal plane. Okay, in top view. Front. If you see that first structure, and have you ever observed dog? They have straight leg. Human being used to stand straight, but if you see that lizard, so the reptile has such kind of structure. Their foot are coming in the outward direction. Leg are coming in the outward direction. Okay. Mammals like dog, cow, buffalo, they have straight foots, and they have 4 foots. Okay. If you see cockroach and other, they used to walk and that like this. This is crabs. They used to walk like as a inclined plane in one direction. Okay. This is from sagittal plane that I'm telling. This is frontal plane and this is sagittal plane. So you can visualize like this. Okay. So this is like crab. So to understand the human locomotion of bipedal, it is essential that how many legs are there, what is their position, and what is their size. So this is your lizard and this one. This is some cockroach and other structures. If it is straight, then it is dog. So mammal and reptile has different form of shape, not as well as their direction also of leg is different. Positioning of leg is also different. Shape is different. So that is broadly we are classifying 3 categories of legs is possible to say. One is that which is bending in inward direction. One is that is going in the outward direction. Another is that they are shifting in case of where they are in the only moving in the one direction. Okay. Now the question are coming arising as human being has all leg length are equal as well as dog and other. But some species like this octopus and other, they have different leg length also. And there is speed is also different. Many times you can see that such architecture in which some legs are tall and some is small. Okay. So you see that like in this case, these 2 legs are relatively small compared to this one. Okay. So placement of leg, number of leg, and their length is very important because reptile has to climb over stair. This is wall. We cannot climb on the wall. The limitation is there. So that's why they have to keep the grips. That's why their shape is like this way. Okay. Now I'm coming on the gait, human walking, GAIT gait, that term. Okay. And before I dig more in depth, it is pattern of foot placement. And it is one gait cycle. That's why it is becoming the biometric because we used to repeat it again and again. Okay. When we are walking 10 kilometer, 20 kilometer, we used to. Have you ever observed that human being can start running, walking, brisk walk, slow walk, fast walk? We can perform different. We can start jumping. And an afternoon session, I will talk about human activity. That time I will talk about jump, squat, and all sort of things. How you can do. So how it is possible? If you have no knee joints, can you jump? No. Can you perform different sort of walk? No. So these joints are giving some degree of freedoms, which helping us to gain essential behavior like walking. Perform different sort of walking at different speeds, 2 kilometer, 3 kilometer, 4 kilometer, which we can do in the treadmill. Okay. Now I'm coming on static balance and dynamic balance. Static balance when you are standing, dynamic when you are playing tennis or badminton. Momentally you are unstable, but you will become the stable. So for this, you see that there is center of mass, and the position of center of mass should fall on the support polygon formed by your leg. If you have 4 legs, then there is different support polygon. If it is 2 legs, then it is different support. If this projection, that means there is one vector is this one, and the vector is this one. If you are taking dot product of these vectors, let us assume this is A and this is B. Take the dot product A dot B. So modulus of A modulus B cos theta, the angle between both. Then it will show the projection of this vector A over this support polygon. And if it is falling within this region, I will consider that the walk is static and balanced. Dynamically balanced when you have body has motion. Okay, it is having motion. So what will happen if you have motion? Maybe momentarily you are unstable, but once you will place your foot on the ground, you will become stable. So like I will show that. Now the gait pattern for quadruped animal you can understand, which has 4 legs. So at a time I am using only 2 legs, and rest 2 legs helping me to move in forward direction. If you have no swing leg, your foot is not, you are not lifting your foot in the air, you will not able to walk in the forward direction. The reason is that it is swing phase. It used to give proportion or force to move in the forward direction. Okay. So if you see that the black dots, foots are placed on the ground, white is in the air, that means in the swing phase. So you have effectively 4 leg animal. If it has left back, left front, right back, there are 4 legs. At a time, only 2 foots are time. This is time series data as you are moving in the forward direction. So time series data is your volume. So you see that at time t1 only left back and the right foot. This is the position in the ground. Another time is what? Time t2. Momentarily 4 are on the ground. That means they are switching. It is possible that both the foot will be in the ground when you are walking. So I think that only 10% of time you'll have both foot are on the ground. Double support phase. There is single support phase when one foot is in the ground, another foot is in the air. There is double support phase when both foot are ground. When you are walking, generally you will hardly observe that your both foot are ground. But switching time when you are moving from one switch mean your foot translation is moving from one foot to another foot. That time maybe your both foot are on the ground, and again depend on your behavior of walking. Okay, so that time your all four foot are on ground. You can see that at time T2, this is changeover. You are moving from T1 to T3. Again at T3, only two legs are there, and this time the rest two legs are in the ground, and the foot which was in the ground, it is in the air. Again changeover. So this way, the pattern of evolving, and you can analyze the human walking pattern by seeing their trajectory, by applying force sensor on the base of your foot. You can also analyze. You can take one robots which are already walking, place some force sensor. You can measure the force, how much force is applied. Okay. So in leg draw motion, what is passive and active? So you have certain joints. You have hip joints, knee joint, and ankle joints. So actuator are there. It's actual muscles which used to work. Okay. So if you first diagram, you see that I'm using certain motors, servo motor are there, and they are controlled by the microcontroller, and there is motor by which we are working. That is we call active bipedal. In passive bipedal, when we use gravitational energy, there is no source of energy like motor and other. In this case, they are working in inclined plane, and there is no knee joints. We have also designed. I will show this also. And always motion is going to analyze in two plane. One is frontal plane, another is sagittal plane. Frontal plane, if you see that left direction is frontal plane, this is my frontal plane, and this is sagittal plane. From sagittal plane, you can visualize very nicely. You have hip, left hip, right hip, left knee, right knee, left ankle and right ankle. So when you are moving forward, I think you will help with the help of, you will swing around your hip. Okay, movement is helping around hip, because hip joint has 3 degrees of freedom, knee joint has 1 degree of freedom, ankle joint has 2 degrees. Effectively, entire human body has 25 degrees of freedoms. So somewhere they are referring it as a degree of mobility, extra degree, because according to them, any solid has maximum 6 degrees of freedom. They can rotate around XYZ axis, they can move around XY. That's why 6 degrees of freedom, 3 translation and 3 rotation. Later on, we'll introduce in the kinematics or mathematical foundation these things. Okay, and each joint has certain trajectories, working pattern. Then only it is unique. If there is no pattern, I cannot use for biometric identification. From this motivation, I'm moving. And there is another important factor is zero movement point, ZMP. And for understanding the human walk, we have to understand the ZMP trajectory also. Zero movement point. It is not any static point, it is dynamic point, because it is moving. It is moving from here to here, and then it is passed to another leg. Here another leg ka start hoga, and it is passing to this leg. So it is coordination of left leg, right leg, left leg, right. So human gait is involving left leg, right leg motion both. If it is center of mass stage, it is starting from your this portion, back portion, and it is passing through there, and it is going through your toe. And here you will understand the autonomy, anatomy, how human leg is designed, foot is designed. In this case, you can see that rest four toes, rest four fingers are small size. Why? Only thumb, this thumb is bigger size. The reason is that because they are not sustaining that force, because the trajectory of ZMP is not passing through these fingers. So these are small size and this is bigger size, because it has to sustain that force, to apply this force. So always you see that there is always the region which is touching the ground. कभी भी ये portion touch नहीं होता ground में, ये ऊपर होता है. That is okay, because they are not effectively taking the force. So human, you can understand that how human leg is, foot is designed. And same thing people has inspired from here. And if you see the leg, shoe joints. तो जिन लोगों ने shoe देखा है, they can understand that why we are wearing shoe from behind. Why not from front? You can put. पीछे से ही जूते में आप अपना पैर डालते हैं. The reason is that your ZMP is starting from this point only. The ZMP trajectory is starting. And nowadays in IIT Delhi, maybe Deepak Joshi sir will introduce this later on. They are designing the Jaipuri shoes in the very sophisticated way, like Adidas and others, so that they can. So these are some research issues in the bipedal locomotion which you can pursue and work. One is we require energy optimal trajectory, and the moment or whenever I will talk about human locomotion or anything related to human, it is highly optimal things. Nature is best optimal source, and from here if you are inspiring, so we have always scope to optimize the things. So we require energy optimal trajectories or walking for obstacle avoidance as well as staircase climb or as well as normal walk, because when you are climbing over a staircase or trying to avoid the obstacle, that time you require more energy, so you require such a way so that you can optimize the energy. Okay. Second thing, to observe these things to avoid these pressures which are applying on the foot, so we can use soft sole. Okay, so that it can be uniform distributed, and we can absorb a little bit, like you have seen that in buses also you have sockers like this on the foot of bipedal as effect of energy. To optimize energy, this is also the way. We have to compliance of each joints on the energy. Each joints has different degree of freedoms, different compliance. They are like hip joints, you can move front and back, left and right, and you can rotate with the help of hip. Knee joint has only 1 degree of freedom, so we have to compliance with the human architecture and their effect, what motion we are giving, whether it is fruitful or not. Okay. So this was the research issue which you can work. Now I'm introducing human walk, which is I'm telling GITK, human locomotion or humanoid locomotion or bipedal locomotion. Now I think that bipedal, humanoid, human being, gait, it is clear. Okay. So it is 3-step process. When same limb, if you see that this is black foot and it is striking on the ground again, then I will see that one gait cycle is complete. That is heel strike. There is 2 major events. One is toe off, another is heel strike. So first I need to quantify the what is gait cycle, which period I use to repeat and again. It is the time between successive foot contact of the same limbs. When same foot will contact on the ground again, then I will say that it is one gait cycle complete. So one gait cycle begin when the reference foot contact the ground and end the subsequent foot contact the same. So this is what gait cycle. So in gait cycle, what is happening? This is striking, and then you are coming across swing phase, stance phase, and always consider both the leg. It is not like that one foot is coming the swing and stance. Similarly, another foot will come in the swing and stance. So you have three stance phases. Okay, first left stances, then both foot are in a stance phase, and then right stance, effectively for walking. If you have seen that my previous video that I saw that starting when I was defining locomotion. So we used to divide entire human walking data, that is time series data, for one gait cycle into 8 phases. That is starting with rolling response 0 to 12%, then mid stance 2 to 30%, then terminal stance. So this is stance phase initially, and then swing phase. Okay. So stance phase is generally for 40% of time, and rest 60% of time you have swing phase. Similarly, this is for another leg also. So when your left foot is in the stance phase, right foot is in the swing phase, and when your right foot is in the swing phase, left foot will be in the stance phase. Apart from there, you have to also understand there is 3 plane in which we can analyze the human walk. That is already I introduced. One is frontal plane, this is called cornel plane. Another is sagittal plane, which is divided into left and right. And third is the traversal plane and top view plane. If you can see that human walk, this is considered as a human leg is a inverted pendulum. It is moving in the forward direction, and each joints are getting certain pattern. Okay, that pattern also I will show. So this is for hip joints, left hip joints. This is coming only sinusoidal. This is for one gait cycle, another gait cycle, third gait cycle, fourth gait cycle. A generally healthy person can complete one gait cycle within 1 second, less than 1 second. Okay. Then if you go for knee joints, this is first gait cycle, and it is the behavior is big hump, small hump. Whereas you see the ankle, small hump and big hump. And you try to find the analogy between this one. When here is big hump, here is small hump. Where is big hump, there is small hump. That means knee and ankle joints are inversely related. And that is true. When we are really striking on the ground, that means ankle joint is highly activated, knee joint is least activated. When you are moving forwards, your knee joints is bending, that time knee joint is highly activated and ankle joints are least activated. So this is how coordinated behavior we are designing so that we can walk in the forward direction. Static and dynamic walk already I introduced. This is center of mass. If projection of center of mass support following your the polygon which is formed by your foot, support polygon. Okay, so that is again convex walk problem. So we'll tell that that is static walk. When you are playing, maybe you are momentally unstable because your projection of center of mass is not passing through your support polygon and you are momentally unstable. But once you place another foot on the ground, then it is becoming stable. So now let us move toward the discussion where I will show the different bipedal robots. Okay, already I introduced this terminology. Okay, so there is some state of art robot available. Some robots are ZMP based, zero movement point based robot. Another is foot placement or capability based model. Third category of robot is hybrid zero dynamics. And fourth is passive models. There is based on their design and different utilities, they are divided. Okay, all robots are capable to mimic some human behavior and each has its own unique advantage. I'm starting with motivation, why we are going to design the robot which is very similar to human being. The reason is that the human being is here and it is highly energy efficient as well as more degree of freedom. They are highly agile. And if in case of robot, if you see that this big dog, as agility is increasing, the energy efficiency is very less. And if you are going for passive walker, you are losing certain degree of freedom, but it has high energy efficiency. So you have to do trade-off between energy efficiency, agility is optimal energy, agility is required more degree of freedom. So in this direction, first let us understand the passive model and the robot which was designed in corner. You can see this video. And it has participated in the marathon and it won the marathon also. This is what corner robot, human participant was there. So they have participated in this competition marathon. Okay, the robot is now, it is here robot. So it has no knee joints, 2 legs, effectively with the motion of hip and the toe, it is walking. So due to the gravity and other effect, it is walking. So finally, it has won the competition. So let us understand some benefits of these robots. What are the benefits of these robots? So they have minimal actuation. That means they have only toe push and the leg swing. There is only the motion by which I can move. So you have 2 joints. You are applying force in the forward direction, that is considered toe push, and the leg swing when you are pulling back, your foot is in the air, that is considered a leg. With these 2 actuation, you are able to. The benefit is that it is highly energy efficient passive walker. So it is with a single set of battery, it cover almost 63 kilometers. That is positive point. But there are 2 negative points also. One is there is no knee joint, so it cannot it cannot clear the obstacle. That is the problem. Another is that one gait, one speed. It is not like we have different speed or different style jumping and all sort of things. It cannot. So that is 2011 kernel robots. We'll see the other category of robot also. Now I'm coming on ZMP, zero movement points. And such robot has always flat foot. And these robots are bending knee also. They are not standing like straight human. And there is reason to avoid the singularity qualification. As I told that I cannot keep my hand all the time straight. It will require more energy. And such case you require, in case of machine, you require motor which can burn the motor. So to avoid such things, we require to avoid the configuration which is leading for singularity. Okay. So we have zero moment point robots. The point on the ground where all the reactant force are zero, that is considered as zero moment points. That means from left and right forward direction. So in flat terrain, it is okay. But when you are moving in inclined plane, you will always stumble, you will not able to walk. And that is very much motivated, which you have seen the industrial robots. In industrial robots, if you have seen that Puma robots and bicycle, which is walking with the, you are driving bicycle with the help of two tire only. Their architecture is always following this ZMP. Okay, so you try to keep the points on the ground where all the reactant force are zero. If any torque is generating, you will not able to walk. So here flat foot. The reason is flat foot. There is point foot as well as flat foot. So human's foots are not like that. Human foot is always cone-shaped foots. Okay. So the example is SMO robot. So you can see the capabilities of SMO robot designed by Honda. And recently, Boston Dynamics also had provided service. Maybe Hyundai Motor has purchased or acquired this Boston Dynamics that I saw. This is Honda robot. Toyota also has very small robot, very utility-based robots. So this robot always it is walking in a bending knee. The reason is that it cannot stand straight. If it is getting straight, the motor will burn. And they have flat foot. So they can walk in the flat terrain very perfectly, but they cannot walk in it. So it has capability running in the flat, we call it agility. It has maneuver around left and right hip capabilities, jumping, some gesture also it is going. Some typical behavior also I show, park over. Okay, the robot is walking over different wall. They are climbing like human being. Parkour. It's like climbing over a stair, but they are selecting only flat terrain. Okay. Serving food. So they can be utilized by hotel industry, hospitality industry to provide food, beverage, certain things to robot. Okay. They are obeying. The instruction is given. The pre-fitted robot is there. There are various computer vision sensor based robots, camera, which is capturing particular location and work. Okay. So it is serving the people. That is ZMP based robot. There is some big advancement in the robot is big dog. And I think that if I'm delivering talk on the robots and if I'm not discussing big dog, then it is not justice with the robotic industry. That is Boston Dynamics and DARPA also working, Defense Research Organization of USA. So they are also planning this used to carry the luggage or food to army people, US Army. And this robot or this dog has capabilities to walk over different surface, different terrain. It is walking over slippery surface, forest, in simple road. It has such a sophisticated push recovery capability. The person has applied the high magnitude force. The robot was able to recover slippery surface it is walking. That is also developed by the Boston Dynamics. These are some big advancement in the field of robotics. Then it is walking over snow. it started running. The speed is also changing. Like tiger. Last time showing Atlas robot, so you can see that how laboratory inside the lab, that is Boston Dynamics. Now Hyundai Motor has acquired this. Okay, maybe I can. So they are using that is cherry press, which paper I have shown you. Okay, so you see that it is walking over which terrains they are first preparing. There is simulator 3D model, motion design in the 3D. Okay, they are giving the capabilities like the behavior, Parker. Okay, that is very difficult behavior. They are also analyzing the joint rigidities. Okay, like it is walking. It is walking over inclined plane. Like climbing over different walls. That is the what effect will be very difficult behavior Parker. They are using hydraulic motor. 3D diagrams you can see. And they are doing repeatedly. Many times they can get crash and they can find the difficulties it can get. And like it is like athletes also, they used to acquire behavior. It is not like single times. They used to practice lot and lot. And they used to learn this behavior. Similarly, they are learning. Software things, which is designing robots, designing. So you have seen the extreme capabilities of bipedal robot, what robot was doing currently. Boston Dynamics are working in the Dyson and all sort of things, park over behavior, jumping, and all capabilities they have. Now I'm coming how to design or inspire. They have designed through the human being. So human architecture is very similar. So we have taken the motivation from there. Their torso, which is like your upper portion, then your hip joints, which are effectively 3 degrees of freedom. The knee joint is 1 degree of freedom. Ankle is 2 degrees. Or toe joints, we are generally not concerned, but this is extra degree of freedom. So we are trying to evolve or design a system which is motivating from there. Then we are trying to see a different kind of force which human anatomy used to observe, like ground reaction force, zero movement point, center of pressure. So this is center of pressure points on the line of zero movement due to the gravity. Okay. Center momentum points. Okay, line of zero moment. So this is force is passing through this center of mass. So this way you can analyze different forces applying on the bodies. Okay, already you have seen that if there is no effective torque, torque is zero. This is your things. In this case, you require some extra torque is coming forward, so you require to balance this structure. Different level in which you can walk. So level ground, inclined ground, staircase ground, and uneven ground is required. So that is very important to walk over this one. Okay, so different challenges are associated with when you are walking with the different terrains. Okay, so now let us analyze human walk in the depth. First, let us understand what is step length, what is stride length, then gait cycle, what is swing phase, stance phase, what is foot translation trajectories. Apart from there, you can quantify with the certain, these are certain static parameter and dynamic. Static parameter like your weight, age, gender, height, because these capabilities depend on these parameter also. If you're an athletic person, you will have better push recovery capability. If you are a normal human being, you will have less push recovery capabilities. So there is step length size is depending how long you are taking step. That is left step, right step, and then left step again. So in stride phase, this is combination of two step length, left plus right length. Okay. So step length is distance between the heel contact point of one foot to another foot. That is what is step length. Then stride length is the distance between successive heel contact point of same foot. So normally it is 2 times of. If you see the left hand side, first you have to see that when you have swing phase, so this translation trajectory is moving. Transmission rate. Stance phase, it is straight line. Swing phase, it is moving ahead. Stance phase, it is moving like. So what is happening when left foot, you have to understand it is in depth. When left foot is in the swing phase, right foot is in the stance phase. Again, right foot is coming in the swing phase, left foot is coming in the stance phase. Again, for one gait cycle, I require one more step. Left foot is in stance phase and right foot in the swing phase. Right foot is in the swing phase, left. So this way I'm moving. Very momently, if you see that very less amount of time, only 10% of one gait cycle, you'll find double support phase. This is your double support phase when your both foot are on the ground. This is one gait cycle period. 3 step, left foot, right foot, and left. Okay. And this is defined left step length, right step length, and one more left step length. Okay. And this is left plus right step. I think that this diagram is clear. If you have any doubt, you can ask question from me. If you have any doubt to understanding these terminologies and things, you can ask me. Okay. So here I have demonstrated how foot translation trajectory are moving left and right coordinated together. And when one foot is in the swing phase, another is stance phase. So swing phase is total 40%, 60% of one gait cycle, and 40% is stance phase. And double support phase is always only 10% of entire gait cycle. That I will demonstrate. So this is, you can see that in gait cycle, this is double support phase. Okay. Now I'm coming on, I'm not going in this how controller is designed and how automata based model is designed, but that is inspired from this rocking block model. In rocking block model, what we have done, we have considered the human architecture, which is moving around your center of mass, forward and backward direction, to and fro. In the direction we are moving, and that is joint angle we are making from center of mass when we are moving forward. So similarly, the OpenSim software was available in which they have provided this model, and the beauty of this model, this has cone shape of foot, which is very similar to human sim. And the rocking block, if you have seen the temple, in the temple top there is tomb. It is, the architecture is never attached with the temple, but it is never falling during earthquake. The architecture is so balanced. The center of mass is passing through your ground. The center of mass rigidity is passing through your support polygon. You are always stable. Okay. So similarly, we have motivated from there and we have taken this impact. Okay. We have designed zero movement point based model. From here we have inspired and we have designed hybrid automata based model. I'm coming on directly. There is different experimental setup which we have conducted, and afternoon session I will show how we are capturing the data. These are the different software. We have collaboration with the Monash University, Malaysia. So there is to capture the human body posture, we are using IMU sensors. Okay. So afternoon I will see. This is 3D visualization by which you can see data collection. I'm directly coming on how we are capturing the, and there is some publication which you can refer. IEEE sensor paper is there, generation of joint rigidity using hybrid automata based model, which I'm going to explore now. This also you can see that IEEE tension. This is IEEE sensor paper, some papers which you can do. Now I'm coming on hybrid automata model. That is like control strategy or robot walking. Okay. So automata, as a computer science student, maybe you are aware, automata model, which is mapping automatic or discretized behavior. Okay, if you have discrete stage, 8 discrete stage, you can define the 8 stage automata. But apart from there, if you have 1 minute. Sorry for interrupt. Now, if you have only discrete states, then it is simple automata. But if you have continuous behavior, then it is hybrid automata. So you can understand, like you have 4-gear car. You are in gear first. Your speed is continuously increasing from 0 to 10 kilometer. Once you are crossing 10 kilometer, it is reaching to another states. Okay. So there is dynamic behavior which is evolving particular state, like 0 to 10. I mean, it is state 1. That is mean you are automatic state 1. Then you are moving state 2, state 3. But each state has some dynamic behavior, which is defined by your first order differential equation like velocity or some time. So as we know that gate is broadly divided into stance and swing phase for this is experiment purpose. And the tapas which required to define a hybrid automata model, because the automata is very well defined and widely acceptable tool in the computer science. So we have accepted this one. Okay. So in this case, you have 8 tapas. Q is defining number of discrete states. X is defining that continuous variable. When you are at particular state, the variable is changing. Then you have movement, translation from one state to another translation. So you have a state with the particular continuous variables. You are moving another state, but you are getting multiple TZT. Then each state you can initialize. You have initial value, then domain, because you cannot rotate your leg 360 degree. You have certain boundary on in which you can rotate. You have age also. Guard condition when you switch from one state to another state. And once you are in particular state, because we are giving in the robot, then we have the set map. So these are the 8 tuples. So now you can see that you have initial contact, loading response, mid stance, terminal stance, pre-swing, initial swing, mid swing, and terminal swing. There is some initialized condition. So initialize, you have 6 joint angle, hip, knee, and ankle of left and right leg. As it is time series data. So time series data, it is initially you are at a time 0 here. then after certain time you are moving from second states, and either your joint angle value is changed. So there is two guard conditions when you switch from one state to another state. One is that time series data, another is that your angle values. Okay, and this is your domain range in which you can vary each joint angle, whether it is hip, knee, or ankle, or time also. Like 0 to 10% time here, 10 to 20% time here. The beauty of this state, if robot got stuck in any state, you can start from here. You can initialize all values with the initial value of start. So this way we can run, and this is we have designed the model. And as I was telling that there is app equal to Q into T vector fields I am getting. So these vector fields we have generated for all TGT. We have not considered here knee joints. Okay. So here left ankle, left here, right hip. So we have plotted these TGTs. From here we have selected only optimal TGT, one or two TGT, and try to see that how energy efficient it is. And then we have generated these models. Okay, so we have compared. There is HOPE2 model, which is already well established model, and two TGT vector TGT we have taken, and one hybrid automata, and we try to compare, and we found that it is almost getting sinusoidal kind of curves. All four TGT are equivalent. So our generated TGT through vector field is also correct, or hybrid automata model is correct. Similarly for ankle joints also we have taken. Finally, what we have done, the model is available, and this model we have tested. This is provided by the Stanford University Open Sim software, and the beauty of this model is that it has cone shape of foot, so it is very similar to human being. It has hip joints, knee joints, ankle joints. Initially, the model was not working, and we have provided our hybrid automata based generated TGT, and by this the model was able to work. And the parameter was left thigh length, shank length, foot length, torso mass, shank mass, and mass we are not considering. Okay. You can see also the video here how model is working. So in this case, what is happening in the first model? The model was initially not working. Okay, until there was no TGT were provided, but we have provided the hybrid automata based TGTs now. The model is effectively working 3 steps, and you can see here the TGT. Red color is your hip, and the blue color is your knee joint. So hip joint is almost sinusoidal curve. The time series data is shown by this arrow, and one gait cycle we are getting one hump. Okay, and for knee joints, small hump and big jumps we are getting. So these models are working, and this is some standard gait data. It is model. So if model is working, it does not solve my purpose. Just my purpose was not to apply on model, and I need to check whether model is stable or not. The working TGT is stable or not. That things I need to validate. To validation purpose, we have plotted, compare with the other standard gait data of walking. Okay, as you see that we have considered gait 2354 model of OpenSim. It has 23 degree of freedom and 54 muscles. We have compared hybrid automata model and normal human being data which have captured, which I will explore in the second afternoon session, where we will discuss these things. Okay. So almost everyone is giving similar TGTs. Joint angle is recorded in degree, and the time series in the millisecond. And if you see that this is minus 30 to 30, this is the range in which particular joint can move. Like right hip joints can move minus 30 to 30, left hip joints also. Ankle joint is moving minus 70 to plus 10, this way in degree. And another observation you see, if this is left hip, this is right hip. They have just 180 degree phase difference. You just place the mirror in between, you will find the right TGT compared to the left TGT. So this is also the validation portion where we are trying to validate our generated TGT are correct and stable. Second, that limit cycle curve, and that is very famous, in which we are doing both theta versus theta dot, the theta quantity. So angular displacement versus angular velocity. And if you are getting closed cycle, and this is for one cycle, and if you are getting multiple cycle and they are not crossing each other, that means this phase plot or limit cycle curve is stable. As we know that we have two major events when you are switching from heel strike, when your heel is striking on ground, when you are moving from swing phase. That means switching to swing phase, the heel strike event will happen. Okay. Again, swing legs while knee strikes. When you are knee striking, then swing phase is there. When you are switching to stance phase, then you are getting heel strike and stance leg while knee strike. So there is four major event. Due to this, small hump is coming in, changes is coming in this circular wave. So we have plotted for all 8 trajectories, 6 trajectories, but ankle I have not included here. The reason was ankle joints was little bit suffering, and the ankle joints, the data which I have collected, it was not very similar to human joints. That's why I am not consider these ankle joints. Okay, so you see that all this is from multiple gait cycle data, and all gait data is closely following the trajectories. They are stable. Hence, we can say that our trajectories are stable. Okay. Then we have further performed this stick diagrams prepared in the MATLAB. So you can see that this is your thigh. This is your thigh. This is your shank, and this is your foot. So this is left foot. Then left foot is coming in swing phase. Right foot is coming on the ground. This way we are comparing. So we have compared with the gate 23 model as well as our hybrid automata model. Finally, we have tested the generated trajectory over the real or simulated humanoid models, and we have achieved. The model was able to walk. This humanoid model, this Hope2 model was available, and that is again for Bipedal, Fujitsu has contributed. So they have models, and in model we have applied hip and ankle strategy. Ankle trajectory we have provided, and the model was able to work, and there is controller, and it is done in the Bipedal software. The beauty of Bipedal software that you can write the controller in the MATLAB, Python, C, C++, Java, and it is open source simulator. You can also download, and you can find the now robots, different humanoid robots, Atlas robot models available here. So here I will conclude my talk as I was also approaching toward 11. Okay, so the concluding remarks, we started understanding the human walk, especially for bipedal robot walk generation. We have observed that the leg length, leg position, and number of leg are important. The locomotion walk is naturally evolved process. We used to learn through the environments when baby or human being used to interact with the environments. It is the studies using for wide number of purpose, like understanding the biomechanism of human walking pattern, understanding the cognitive declines, finding the various diseases which we can diagnose, like freezing of gaits, Parkinson diseases, all sort of things. The walk can be utilized for robot walk generation as entire human infrastructure is designed as a human habitat. And last but not least, it was using for biometric identification. Okay. After that, we have seen that how different robots has designed, what is the importance of number of joints, what is the importance of energy efficient walk. These things we have seen, and these things we have not demonstrated you, but we have analyzed, and maybe in subsequent presentation in afternoon I will tell you. We have analyzed the gait pattern of human walk, and we found that if you are left-handed person, your right joint are more activated, and right-handed person, your left joint are more activated. Second thing, knee joint is always more activated, so that's why knee replacement is required. Another thing, morphological similar structure can have same gait pattern. The thing is that if two persons with the same morphology, height, weight, and this one, in this case, we can interchange one another gait. Those I have claimed that gait is very unique. Biometric identification, no one can replace, and if it is biometric identification, we cannot use another one. But if two morphological similar structure, they can use. The final concluding remark is that we have used strong theoretical framework of computer science, that is hybrid automata, which provides the necessary scalability and the journey characteristics. That means the model is not the very much person dependent. It is very generic. Okay, they are not model dependent. Just you are giving certain inputs. My hybrid automata model is generating TJT in which we are providing to model. Okay. And we have also proved that stability analysis the generated TJT of hybrid automata model. Hybrid automata was the 8-state automata was designed. The beauty of 8 stage, any stage I can reinitialize, I can reset the value. So with this, I will stop my talk here, and I will open the forum for question answering. You can write in chat box as well as you can ask orally also me. If you have any doubts, PPT I will share by afternoon. Okay. So okay. If you have any doubt, you can ask doubt from me. And so I'm done with my talk. I'm seeing the chat box. You can write in the chat box. You can. Am I audible to everyone? Yes. You can ask any research question, any technical. Yes, yes, yes.
Any participants would like to ask any question? You can write your question on chat box.
Okay.
So we have another combined AICT inaugural program at 11 to 11:30. So sir has to finish before 11. So I think nobody is asking any question.
Yes, sir. Yeah.
So we can conclude this session.
1 minute,
so much,
sir. There is one question I received, little bit different. Can we extract the kinematic data from OpenShift software? Okay, one question I received from the Harishankar Kumar. Yes, yes. From OpenSim software, if you have explored in OpenSim, you can solve inverse kinematic problem, forward kinematics. You can extract the kinematics data, joint angles. In forward kinematics, I'm capturing the joint angle values. Okay. And in inverse kinematics, I'm trying to get joint angle value from given coordinates, so we can easily get kinematics data. Those I have doubt whether dynamics we cannot implement, but inverse kinematics we can show. If I will get time, I will demonstrate this also in some session. How we are solving inverse kinematic problem, how we are mimicking two morphological similar structure. That is possible. Yeah. They are giving liberty, each joints, each parameters, mass you can ignore, but other things you can get. Okay, sir. I think that there is no more question. We can conclude. Yeah.
Okay, thank you, Bhaskar sir. So this session was very informative, in which we covered a lot of important topics of robotics. And then I think, sir, we have a live session directly from the AICT at 11 o'clock. So participants are requested to join the session at 11 o'clock dot, and then they may take the 10-minute rest. So we will join again at 11.
Okay. Thank you.
Thank you. Thank you, everyone.